Hello everyone, welcome back to the second class of wastewater treatment. So in the first class we have learned about the sources of wastewater and why it is really important to treat the water or the wastewater we produce our everyday life. And now we're going to discuss about that what are the steps involved in the wastewater treatment. So basically, you can see that types of treatment are basically the mechanical treatment, then we will have biological treatment, and then chemical treatment. So in the mechanical treatment, it's basically we have the objective is to remove the large particles from the wastewater. It could be sand, and then the very small particle which would be removed by sedimentation. In the biological treatment, we'll be seeing that how to remove that biodegradable materials, which are basically organic materials. And there are two different methods. One is trickling, bed filter, and another one is activated sludge. And then chemical treatment is basically whatever that microorganism produced during the biological treatment, how to remove. So we call it disinfection method. Okay, so these are the very important steps that are generally involved in wastewater treatment plant. So the overall process are basically divided into five different steps. One is preliminary treatment, where we generally remove all the solid materials or big objects coming with the water stream or wastewater. Then we have primary treatment. There we'll remove the small particles. Then secondary treatment, which again basically that biological treatment method where we remove all the organic material, tertiary treatment to disinfect that water, and then sludge digestion, basically whatever that waste we produce during that process of wastewater treatment, how we deal with it. So those steps will be involved in that wastewater treatment plant. Okay, so this is the overall plant or the flow chart that looks like. So basically, this is the collection system which is collected from different household or runoff or industry. Generally, industry doesn't send this to the wastewater plant treatment plant because they do by themselves in the on-site. So once it's collected, then it is influent water. There is a bar screener which basically remove all the big objects, which we also call as a filtration. And then we have a grit removal chamber where small particle like grit or sand will be removed in this particular steps. And then we have sedimentation. Sedimentation basically, so even though grades are a little bit heavy or sand particle, but there are also small particles which are uh, generally floating around with a little bit of flow of water. But if you let it stay for quite a long time, it will settle down at the bottom. So this is called sedimentation tank. And then we have the aeration tank where we generally have that biological treatment method process. So aeration, basically we bubble a lot of oxygen through the water so that we can incorporate or infuse a lot of oxygen molecule, and then the water will contain a lot of microorganism or bacteria that will digest that small organic particles present in wastewater. And then from there we take out that clean water, and then clean water will be coming to the nutrient removal plant, which basically different salt, metal salt present there, we also known as TDS. So there will be removed, and then this is also another plant happen is that another thing happening this here is that we can bring down all this sludge. Sludge basically it is this all the bacteria, so that can be taken out or from there. And then after we remove all this nutrient which is salt, then you can bring it to that another sedimentation tank, and from there we can go to the disinfection chamber where you can use different methods like chlorine treatment or UV light treatment, or we can have ozone treatment. Okay, and finally that should be discharged, or it can take to another plant where it would be purified further for normal daily use or for drinking water. Okay, so whatever we have all these organic material as microorganism that actually collected here as a sludge. Then these sludge will be sent for further treatment. Like we can throw it into a landfill, which we discuss in the solid waste management, uh, or we can do incineration to burn everything out. So there are different steps involved. So this is the water flow chart. We'll be discussing one by one in the following slides. Okay, so this is the bird skinner. So basically, this is called preliminary treatment. So we have basically that like metal birds, which will filter out all the big objects, like you can see in this picture. Whatever we have, looks very small, but sometimes we can encounter big particles, which will be removed through this bird skinner. And you can see there are multiple bird skinner present with multiple pore sizes, and that would be to remove that small object from this. So with the overall idea of this particular step is to remove the small solid object, which is for heterogeneous mixture of water, wastewater, to get mainly homogeneous mixture. And this is very important step, because if you do not remove all these small particles, what will happen, the pump, because in wastewater treatment when there are huge number of pumps present to push the water from one chamber to another chamber, and if the particles are present in the water, they can damage the pump. So this is the major major step to avoid any damage to the pump, that bars can are present to remove are placed in the water flow so that it can remove all the solid objects. Okay, then we have the grit remover. In the grit remover, what happens is that is the small sand particles or stone. They are actually come to this particular chamber. Okay, and then they're rotated in a particular speed. And during this speed, they will be collected at the bottom, and there will be a belt which will be taking out from the system. So this is basically again to remove the small object or small particle like a sand or small stone particle, which are passed through the bird skinner. They're actually removed from this by using this particular step. So next is a sedimentation tank. So even though we remove the bit heavier materials like sand or stones, there are also some smaller particles which are always floating in the water. So if you really can settle down in a big tank, which can be seen over there, then all these heavy materials will be slowly settled down at the bottom, and then which can be taking out as a sludge from the bottom, and then the clean water can be taken out from the top. Okay, so this is called sedimentation tank. So it allows to suspended particles to settle out of water or wastewater as it flows slowly through the tank. Okay, so you give some time to settle down all this bit heavy, like lighter than the grids material to settle down at the bottom, and then you can remove all these things. Next time is secondary treatment. So the aim is to decompose all the dissolved organic material. Okay, so this is very common organic chemical formula that used by this wastewater treatment plant people. But this is the COHN. So this is basically that the formula of organic compounds which contains carbon, oxygen, hydrogen, and nitrogen. In presence of oxygen and the microorganism, they will digest to ammonia, carbon dioxide, and new microorganism with the chemical formula of C5N87NO2. Okay, so here you can see that white circles are basically oxygen, and then brown circles are basically BOD, which is basically the organic compounds. And then we have bacteria which will digest all these organic molecule in presence of oxygen, and then they will divide and produce more and more bacterial molecules. Okay, and slowly that all these organic molecules present in the wastewater and the oxygen will be consumed. So these are the very important step in the particular wastewater treatment plant. I will discuss a little bit more on this. There is another one called trickling filters or rotating biological contactors. So basically what happened, there are a lot of stones present, okay, and the wastewater is sprayed on top of the stones, and the stones will contain, or it can slowly grow the bacteria. microorganisms or bacteria. So these will be slowly eating up all the organic materials present in the wastewater. So you have to recycle this multiple times because this is there is a continuous flow of water. So the retention time of this organic material will be less, and at the same time, because it is always there is a continuous flow of water, so the efficiency of removal of organic materials will be very less in this particular process. Okay, so this particular process is used for like very rough removal of the wastewater, not very efficient way so that we can use for like daily use or drinking water. So this is not the very good method that could be used for this for sophisticated purposes. Okay, so steps in trickling filter process. So it's a circular tank. So you can see a circular tank. Sewage is sprayed over crushed rock. So there are a huge amount of rocks are there. The slow rotating arm spray is used. So there is like a sprayer will be used. So basically that you can see this. This is the bar where the water is always sprayed on top of that rocks. When sewage moves downwards, microorganisms grow on the rock surface. Food for the microorganisms is organic matters in sewage. After aerobic oxidation, sewage goes to shuttle tank, and in shuttle tank, sludge are removed. And by this process, we can remove only 85% of the organic material. So this is not that much efficient process. So that's I already mentioned that that sludge process is more efficient because it can remove until 95% of the organic materials, which is very important for that water to be used. Now this is the suspended film systems, which basically the activated sludge process. So here you can see we have an aeration tank, and you have or you can have like a blade which can infuse a lot of oxygen into the wastewater, and then that will contain a lot of microorganism or bacteria. So these bacteria will be basically have enough time to consume or decompose all the organic material. So this is very important step over here, and the time retention time will actually change based on the amount of waste you have in the wastewater. Okay, then it will send to the sedimentation tank. You can see that clear water will stay on the top, and these microorganisms will be a little bit heavier, so they will settle down at the bottom, and then the clear water will be coming out. So the whatever we are getting from this tank, that will settle down, and then you can take it back to the aeration tank. Okay, we can return activated sludge. So these microorganisms, so you don't have to grow all the time. So basically whatever you grown at the first time, you can take back and then this return it to the same step in initial step, and then you have, if you have excess, you can just discard it in the other side. Okay, so depending on depending on the amount of waste you present, you can change the time particularly. So you can keep that wastewater with the microorganism for like few days until it goes down. But in case of trickling method, we have seen in the earlier slide where there is a continuous flow. So that is the reason why the efficiency is very less in this particular method. Okay, so there's a few pictures I have given you in the aeration tank. So here you can see that there are huge number of like the system. The pipelines are present at the bottom of the aeration tanks where the oxygen will be coming. So this is the empty tank, and here you can see with the water. So you can see how much bubbling is happening over there. There's another type. This is called diffuser. Turbine is another one. So you can see the turbine, how it can rotate the water in the aeration tank. And this is the empty one, and this is with the water present in that aeration tank. So you can see how with the rotation of this turbine, this will infuse the water, that will increase the amount of dissolved oxygen present in the wastewater, which is very crucial for removing of that organic material from this by the bacteria. And this is another type of infuser or oxygen which can increase the amount of dissolved oxygen, so they can rotate all the time like a fan, and then it can slowly infuse more and more oxygen into the water. Activity sludge process, so basically, which I discussed a little bit in the earlier. So basically activity sludge is a biochemical process to remove the organic matter. Sewage from the primary treatment mixed with the activated sludge, which is basically nothing but the bacteria. It is aerated in aeration tank, so a lot of oxygen molecules will be, or oxygen gas will be infused in the wastewater, because those bacteria need oxygen for survival. So, and they can digest that organic material. Here the oxidation of organic impurities takes place. Sludge settle down in the sedimentation tank, which I showed earlier, and this process can remove until 95% of the value, which is more effective. And you can increase the time of retention time in the aeration tank, and the amount could be a little bit increased, but there is certain, after certain limit it cannot go further, because there are some compounds like nitrogen containing compounds which cannot be digested that easily or quickly by the bacteria. Okay, so that will take until 20 days, but that is too long time. We cannot wait for those that many that long days for a single treatment process of in a day or something. So basically 2 or 3 days are maximum they are taking to clean out all this wastewater in a particular tank, and then this water will either discharge or sent to the another plant for further refinement to get more pure water. Okay. Okay, so this we already discussed a little bit. So basically, this is the aeration tank where we have bacteria that will digest that organic material, and then you can see when this microorganism will be settled down at the bottom, and then the water which is coming out, which is we have around 2 to 10 microgram per liter of organic material. So basically, this is tested with the time and to check if the process is efficient or not. If it is not efficient, then you will send back to that particular aeration tank, and we can wait for a longer time and give the time to the bacteria to digest all this organic material. Okay, so this equation you already have seen earlier. So, but the main idea of this is to remove the organic material on the secondary treatment method. So there is certain large parameters are there. So this is one called MLSS, which is mixed liquid suspended solid. So this is the concentration of the microorganism, which is basically supposed to be 2000 to 4000 milligram per liter of water, so which is basically also depend. This is a huge range, and that depends because this range is because of the amount of waste material present in your wastewater. So that is all basically depending on that amount of waste present in your water, organic material present in your water. If it is less, you can go down to 2000. If it is very high, you can go up to 4000 milligram per liter. The maximum concentration also limited because the air requirement, because if you have more microorganism, you need more and more air, and also the basin size. Okay, so that is also very important. So these are the few important things that people has to keep in mind when they will do the wastewater treatment. Then BOD, we already discussed about the biological oxygen demand, which is basically 2 milligram per liter for a very good or pure water. Too high for the if you have this is if you have too high, there will be a waste of energy. Okay, because the products the produce filamentous microorganism that won't settle down. So basically, this is very important, is that if you have a, if you maintain all the conditions, you will have a spherical bacteria. If you cannot maintain all the parameters, then you have a filamentous. So filamentous will not basically settle down at the bottom of the chamber, they will always float around, and that will be a problematic for the wastewater treatment plant. So basically, if you should always maintain those concentration. It shouldn't be very high, it shouldn't be very less, so that you can get as spherical particles of the bacteria, and that can easily settle down at the bottom in the sedimentation tank, and that you can easily taking out from the wastewater, and then you can get the more pure water from the outside. Okay, so these are the few things that you have to remember. Then hydraulic retention time, that I was telling you earlier, that how long the water should stay in the aeration tank. Okay, so generally it is 2 to 4 24 hours 4 to 24 hours depending on the process. So you can extend it a bit longer, but within 24 hours generally they basically discharge the water from the aeration tank, and they can recycle if it is required. Okay, solid retention time, which is basically how long the microorganism should stay in the aeration tank. Okay, and typically this is to do 8 days of the BOD removal. So this is basically you can reuse them until 8 times, 2 to 8 times, not more than this. So you say after that you should remove it and then try to grow the new bacteria. Okay, food to mass ratio. The ratio is equivalent of BOD per day to per total mass of microorganisms. So basically, how much BOD or organic molecules you have in the water wastewater, and then how much divided by how much molecular microorganisms you need. So this basically BOD per typically it is vary between zero point 0.2 to zero point 0.5, and I told you this is because the range starting from 2000 to 4000 micron per liter. Okay, so that's why the this is very that vary too much. It cannot be too high, it cannot be too low. So again, that the reason should be that it could form the filamentous that the microorganism, or it can produce the spherical. So it should be somewhere in between, so that you get the spherical bacteria, the shape of the bacteria. Lagoon, I told you. So basically, lagoon is not like a kind of a like artificial lake, and if you do not have any waste water treatment plant, what you can really do is that you can dig out this huge pond, and you can simply store your wastewater over there, and then there will all will be happening naturally. But the problem with is that because the lack of oxygen present, if you do not have proper oxygen diffusion in that particular lagoon, you can produce very bad smell. Okay, so your sludge will be always accumulating at the bottom because nobody is there to remove it, and then you have aeration tank, aeration chamber to infuse the oxygen all the time. And so this is the inlet and this is the outlet, but this is not really effective method to remove that organic material from particular your wastewater. Okay, but this is like a kind of cheaper method, but not efficient, and it would produce huge bad smell that may not be kind of tolerable. Okay, so this is a very important thing, and this is some of that particular pictures I have given of lagoon. So you can see there's aeration tanks that they are always uh, uh, the pumps are there to infuse the oxygen into the wastewater, and this is like kind of as I told you, it's not very good. Okay, so this is very cheaper. Okay, improve the public health, and this mainly happen in a rural area where you do not have like a sophisticated wastewater treatment plant, but you can use these such things to reduce the waste present in the wastewater. Okay, so that is a very uh, cheap method of removing your particular waste from the wastewater. Now, tertiary method, there are things that I did not will not discuss too much, because then after remove the organic material, what you have is that inorganic materials, which is very important, which is also we have discussed TDS, total dissolved solids, and they are ionic material. So you could have a cations, you have anions. So how you can do this? So basically there are a few things I have mentioned here: bag filters, drum filters, and disc filters. Now see, I am not going to discuss in details about this, but what basically you can think of, ionic molecules will have a positive cations, you have anionic negative anions. So if you really want to use or remove all these, you can use anion exchange resins. So you can have cationic exchange resins or anionic exchange resins. So if you pass through this, it will take out your cationic species or anionic species, and to release that like the metals or anions which are not harmful, which could be easily removed. Or another way you can do, because you can have electrode, so that can attract the oppositely charged species, and you can remove. In that case, you are not adding any sort of extra ionic species, cations and anions to the water. So there are different ways. So but the idea is that you have to use electronically cationic or anionic species to remove the cations and anions present in the wastewater. Okay, there are other methods are there, so which we are not going to discuss in details. And then Finally comes disinfection method, which is basically all the microorganisms you produce during that sludge method or activity sludge method. You have to use, you have to remove or kill all these bacteria. Otherwise, it will affect your health. Okay, if you use this water. So basically, there is one is called chlorine treatment method. So chlorine, basically you can pass chlorine gas through it, but probably you probably have like smell bleaching in your tap water, and that basically when it is use chlorine as a disinfecting reagent. Okay, so they produce hypochlorite. So hypochlorite is actually present in water and you get the smell, and we often encounter this kind of bleaching smell in tap water. Ultraviolet light treatment, this is very efficient method. Is basically there is like a huge ultraviolet light, and that will kill all these microorganisms present in that water or purified water, I would say. That is very harmless. It cannot produce anything other than the dead cells of bacteria. And the ozone treatment is very efficient, but is also have a lot of side effect, because ozone is not good for the environment. We know the depletion of the ozone layer, and it can produce a lot of smog or fog, on the earth surface. So it can also cause cancer. So we should not use ozone treatment, ozone to treat the or to kill the bacteria. Okay, so these are the few things that people generally use, but ultraviolet light treatment is the most efficient and the safer method to remove or kill the bacteria. Okay, there are a few questions I would like to discuss. So the COD is always higher than the BOD, because BOD is only organic material and COD is basically chemical oxygen demand, so it includes everything present in wastewater. So this should be always higher. Water above the dissolved oxygen content may be considered. Sorry, there is something contaminated, which is like if you have more than 10 milligram per liter, if you have BOD, then we can say this is the contaminated. The condition for the determination of BOD of domestic water is, but the conditions for the determination of, so basically we have to do 2 days, sorry, 5 days incubation and at 25 degrees Celsius. I discussed in earlier, so this is actually in the same topic, so I just kept all these questions. What is the effect of warmer temperature to the faces? So what would happen if you increase the temperature? The dissolved oxygen present in water will be decreased, so there will be no enough oxygen present for their survival, so they will die. In the secondary step, the wastewater treatment dash sludge is used, so we call activated sludge is used under aerobic condition. In wastewater treatment process, the purpose of coagulations and calculation is to remove that bacteria. So basically it is called like a sedimentation tank, so where you have to slowly remove all these bacteria. Lagoon is what is a like artificial lake where we remove that organic material. So it's basically lagoon is an artificial lake, you can say. Grit removal is a preliminary or primary step in the wastewater treatment process. Several pumps are used for what? To circulate that water in the wastewater pump. Disinfection can be done using the three methods we have just discussed. One is chlorination, one is ultraviolet treatment, and ozone. So if you have found any options among these three in your questions or all of the above, so you can take one of them. Okay, so that's all for this second